Hello, dear students. Today we have Proposition 24, Book 1, Proposition 24. If there be two triangles and they have two sides equal to two sides, but the angles contained by those two equal sides respectively, one of them is greater than the other, the triangle with the greater angle will have a greater base. Here we have two triangles, and it's given that two sides are equal to two sides respectively. This side is equal to this side, and this side is equal to this side. But it's also given that this angle is greater than this angle. Thus, it is required to show that this base is greater than this base. It's a really interesting problem. Okay, so let's look at our bag of tricks. I'll tell you in advance, we're going to use that previous prop showing that if there be any angle, you can create an angle equal to that angle on a given line. We're going to cut off from the greater a line equal to the lesser. We're going to use side angle side, and then we're going to show that in any triangle, and we're going to use in the proposition which states that in any triangle which the greater side will subtend the greater angle. So given that one angle is bigger than another, the side which subtends it, opposite to it, will be greater. So the side opposite the greater angle will be greater than the side opposite the lesser angle. We're going to use that one as well. Okay, so let's start off by invoking the proposition where we've proven that if there be two angles, in any given angle, we can make an angle from a point on a line equal to that angle. So let's do that. Let's let it be done. And let this be now our angle equal to it. So now this angle is equal to this angle. Okay? Let's cut off from the greater line, extend this so it's greater. Let's cut off from the greater a line equal to the lesser. All right, say. Let it be done. We know we can do that. Let's connect these 2 points. So now this is equal to this. Okay? And let's connect these points here. This line, connecting these 2 points, and here, connecting these 2 points. Okay, now let's look at this triangle. It's clearly an isosceles triangle. Why do we know that these two sides are equal? Because they're both equal to this. Two things equal to the same thing are equal to each other. Two things equal to the same thing are equal to each other. So we know that, I didn't tell you that, we're going to use that from our bag of knowledge as well, that the angles at the base of an isosceles triangle are equal. Okay? So this is equal to this. But look at this thing. There's two angles here. Okay? Let's go right here. So this whole angle here is greater than the part. But this whole angle is equal to this whole angle. So this is also greater than the part. Great. So this whole angle is much greater than the part. So this angle is much greater than this little angle right here. Now let's look at this triangle. Here you have a triangle such that one angle is much greater than the other angle. So this side will necessarily be greater than this side, okay? This side will necessarily be greater than this side. But we know that this side is equal to this side because we can invoke side angle side. We've got two triangles. Side, angle, side, side, angle, side. Therefore, the base is equal to the base. Great. So if this is equal to this, and this is greater than this, this will also be greater than this. Let's do that one more time. This is greater than this because its triangle, its angle here in this triangle, is greater than this little angle. So the side opposite the greater angle is greater than the side opposite the lesser angle. So this is greater than this. But this is equal to this because they're the base of a side angle side proposition here. So if this is greater than this and this is equal to this is also greater than this. But look at this. This was our original triangle where this side was equal to this side equal to this side, and the angle greater than the other angle. And we've proven then that its base will be greater than the other base. You might have to watch this video again to see all that. But the trick here is the isosceles triangle, angles at the base are equal. Then noticing that the whole angle here is greater than the part, therefore this is greater than the part. And then therefore this whole angle is much greater than this. But this whole angle is also an angle of this triangle. And this little angle is an angle of the same triangle. And this whole angle is greater than it. And we know, we've proven that in any triangle, the side opposite the greater angle is greater than the side opposite the lesser angle. So this is greater than this. But this was proven equal to this, so this must be greater than this as well. It is greater. But this is the base of our original triangle, which had two sides equal to two sides, but the angle being greater than the other angle. Therefore, we have shown that if you're given two triangles such that two sides are equal to two sides, and one angle is greater than the other angle of those angles formed by the equal sides, the triangle with the greater angle will have the greater base. Quod erat demonstrandum. Thank you.